darn, none of them do. But is there something that goes into the 6 that also goes into the 15? Because that could be something that I could factor out of each of them. And I realized, oh yeah, 3s do. Inside of 6, there could be 2 3s. That's really kind of fast. And inside of the 15 here, there would be 5 3s. And 7 and 14, is there something common to them? Yeah, the 7 is. 7, there's just one 7, but there are 2 7s in the 14. And if I now multiply straight across, 2 times 2 is the 4, and 1 times the 5 is the 5, and I've just eliminated all of this work in the middle by cross-canceling like that. And that's really fast and efficient for students. Again, some students say that seems kind of tricky, like how'd you pull that off? That was so easy, does that always work? So I thought I'd show a couple ways to help you understand why that works. Okay, so the first way is to recognize that if you have 6 sevenths times 14 15ths, and you're thinking about how there are 3's in here and 3's in here, well, I could sort of rewrite these fractions, rewrite this equation, and I could make it about addition. So I know that I have 2 3's that make 6. And I know that I have 1 7 makes 7 here. I'm kind of drawing this wrong. I should have said I have 2 3's here, and this over here looks like 5 3's. 1, 2, 3, 4, 5. There's 5 3's. I have 1 7 here, and on top I have 2 7's. 7 plus 7. Okay, now you can see how cross-canceling works here, because you're talking about how this number, there are 2 of them, and down here there are 5 of them. And those are the same things that we worked out when I was back on this page, kind of doing it as one clear step. You see the 2 and you see the 5. You can see the 2 and the 5 right there. I have 1 7 and I have 2 7's, so I'm just proportionally changing them. There's the 1 and there's the 2, the 1 and the 2. And then I would multiply straight across, and I'm going to get 4 fifths, just like I did. You could also look at it like multiplication, because addition and multiplication are clearly related. Multiplication is just repeated addition. So on this side, again, if I said, well, I have 2 times 3, that's the same thing as 3 plus 3. And opposite it, on this side, I have, what's my order I want to do? I want to do 5 times 3 like this. 5 times 3 over there. And I have 1 times 7. And I have 7 times 2, like this, to get the other top part. And then I'm using this phrase that we've used a lot in class, cross out what's common. It's a really handy idea in algebraic work. You're looking for the factor that's common diagonally. Well, it's the 3. So we cross it out, and we cross it out. What's common the other direction? It's the 7. Cross it out, and we're left with those same numbers. I'm left with a 2, just like I had here. I'm left with a 2, just like I had here. I'm left with a 1, just like I was left here. And I'm left with a 5, which is right here. And you might see then when you go back to this sheet, you might see how it was the 7 that was factored out right here. 7 is taken away, and the 7 is taken away. The 3 is right here, and the 3 is right here, and the 3 is right here. One more reason why that works. Any fraction, anytime you have a fraction where the top is the same as the bottom, the numerator and denominator are equal, the fraction is just equal to 1. So if I have a 3 on the top and I have a 3 on the bottom, that's like a 3 over 3. It's a 1. And 1 times anything doesn't change the value of it. So the factor on the numerator and the denominator here kind of cancel each other out. And these two cancel each other out that way. And that's where we get also the idea of the phrase cross-canceling. So hope that video helped.